Biomass? Maybe. This is Jane. This is Jane buying gas. Though high gas prices hurt, here's the big question. Are there hidden costs for alternative fuels? Petroleum byproducts figure into the manufacture of clothing, medicines, plastics, even microchips for our computers. But most important to most people, petroleum is the source of gasoline. Here's the catch. China and India are climbing in behind the wheel, along with the rest of the planet. Petroleum supplies will drop, demand grow. You do the math, and pay at the pump. Rising gas prices are fueling the search for alternative energy sources, like biomass. No, it's not a rock group. It's a word that refers to a bunch of living or recently living stuff, like grassy plants, wood chips, corn, even animal or human doo-doo. What do these have in common? They are rich in hydrogen, carbon, and oxygen molecules that can be converted into chemicals or biofuels, like ethanol or biodiesel. So how are fossil fuels and biofuels different? Well, they both come from living matter. But with fossil fuel, you might start with ancient algae, put it under stupendous pressure, and let it stand for eons and eons and eons, and eventually you pump the crude oil from the earth and turn it into gasoline. For biofuels, on the other hand, you might start with freshly harvested prairie grass or wood chips, force the biomass to jump through a few chemical hoops, and in much less time you get fuel that's potentially better for the environment than gasoline. Why? Because unlike fossil fuels, biofuels recycle carbon dioxide. Here's how it works. Plants remove carbon dioxide from the air as they grow. Then cars release it when the fuel burns, and the next season's crop reuses that carbon dioxide. It's also cool because it's a renewable resource. It's as regular as the return of the 4 seasons. Crops and fast-growing prairie grasses can be harvested year after year. But before we rise to give biomass a standing ovation, we have to admit there are a lot of unanswered questions. How much will it cost to process biomass? Does it take more energy to make biofuels than we get from burning them? Will using crops to make biofuel drive up food prices? Or how will it affect our land and water resources? At the Center for Environmentally Beneficial Catalysis, headquartered at the University of Kansas, we're searching for economical ways to convert biomass into fuels and chemicals without harming nature. One way might be to use really high heat to break down plant fibers into smaller gas molecules that are then reassembled into useful chemicals or fuels. We must evaluate the economic, environmental, and social cost of biomass. A new energy source must be green in every possible way from the start. So, biomass? Maybe. I'm Claudia Bode, the Education Coordinator at CEBC. Thank you for watching. Please visit our website for more information.